All right, so I'm going to stop this share here. Let's see. All right, this is another computer I'm using here. So I just wanted to say that if you go to Blackboard, so everything is almost the same as they were before. Yeah. So, but you will see like all these modules available soon. And I also, let me see, updated this module here. So this is where we left off before spring break. So we covered 3.5. So we have 3.6 and 3.7, and I made 3.8 not to be covered because it doesn't have any kind of like an urgency to be covered. So for now, it's like we don't need it. But if you have time at the end of the semester left, then I can go over 3.8. But again, at this moment, it's not that important to be covered. So essentially, I'm going to change this quiz settings here, as you see. So quiz 7 is not going to be covering 3.7 and 3.8. But you will have quiz 6, and I'll make the room to take the quizzes available for like a few days again. So you will be able to take the quiz whenever you want to. Towards the end of the week, or in the worst case scenario, I can extend the deadline for Monday, because we're going to cover 3.6 today, and then the quiz is going to be on 3.5 and 3.6. Okay, so but I'll make sure like you're not falling behind or something. So I'll make the adjustments to the quizzes and homework assignments as well. And speaking of that, you have the homework of 3.6 already uploaded to the system. One thing that I want to tell you about the homework is, so if let me just show that to you. So remember that earlier we had the upload feature for homework assignments for certain questions. So now we're back to that. And you will see when you get your own Outlook in WebAssign, when you click on 3.6 homework, it says like you're gonna upload the solutions for number 1, number 9, and number 12, and you can do it by simply taking a picture of your work and then upload it to the system as a PDF or JPEG file, which is okay. And I made those optional, as you see. So upload feature optional for those questions. What that means is when you start the homework assignment, there's going to be an upload feature popping in your Outlook. Okay, and once the TA back puts his feedback on, you'll be able to see his feedback in the same homework assignment when you open that back up. Okay, is this part clear for now? If not, just let me know and I'll put it in the chat box. Okay, if it's not clear. Okay, so I don't see anything here, so that means everything looks okay. All right. So at this moment, do you guys have any question? Do you guys have any question? Okay. So let me open the chat box back up here in the other computer. So yeah, whenever you have a question, put it in the chat box so that I can sort of like simultaneously check and see if I can answer your questions. In the near future, you will see that I'm going to make the poll option available. So I'm going to ask the questions through polls. So you'll be able to just hit a button to answer my questions in the future. But for today, I didn't want to make things complicated for you. All right. So all right. So this is there was a problem on the 3.5 homework. There was a problem asking for the tangent line of the function at the point 1, 0. Let me just check what that is. Do you remember what number was it? Just tell me what the question number is. I'll check. Oh, 15. Okay. Let me see. Oh yeah. So use the implicit differentiation for taking the derivative of x plus y minus 1 equals ln of x to the 9 plus y to the 9 at the 0.10. So this is, again, implicit differentiation. In fact, let me just go through a little bit so that we can actually recap certain things from the last lecture. So implicit differentiation means like you're going to take the derivative of the whole equation, okay? The whole equation. You're going to take the prime or the derivative of the whole equation. So, but you're going to keep in mind that whenever you take the derivative with respect to a y term, so that y term is going to be applied to like you're going to use the chain rule for those terms. So, for example, this term is an x term. I'm not really worried about that. But this term is a y term. I'm worried about it, as well as this term. So that means whenever I hit the derivative for those, then I will be making sure that I'm applying the chain rule. Okay. So in that regard, so let's just take the derivative of the left and right hand sides of the equation, term by term. Okay. So the first term is x. So x has the derivative 1. So that's a safe term to take the derivative. And let's check also. Okay. And also you have y. Well, y has the derivative y prime. Okay. And then you have 1 here. So 1 has the derivative 0. So I'm talking about this term now. So that has the derivative 0. So that's minus 0. Okay. So see, like I have y prime coming along. And then you have the ln of a chunk. And we know by the chain rule that ln term has the derivative of the inside. Let me just write that precisely. Prime divided by the inner part of ln. So inner part, you take the derivative, and then you divide by the inner part. Okay. So we're going to be careful for this. So the left-hand side is just y prime plus 1. And the right-hand side is, so I just need to take care of this derivative here, right? So for the first term, that's an x term, so we're not worried about that. We're going to use the power rule for it. So it's 9 times x to the power of 8, right? X to the power of 8. And for this term, I'm going to use the chain rule, so, or generalized power rule, which essentially means that I'm going to put the 9 down and subtract 1 from the power, but I'm going to multiply this by the derivative of this inner part, which is y. And I know that the derivative of y is y prime. Okay? And this is all divided by x to the 9 plus y to the 9. All right, at this moment, I don't want to go further with this, but I hope this gives you an idea. So at this moment, what you're going to do here is to solve this equation for y prime. So this, the rest is just algebra. And then once you are done with that, you're going to plug in 1 for x and 0 for y. Okay? 1 for x and 0 for y. And you're going to evaluate y prime based on those like x and y values, 1 and 0. And once you y prime, the rest is easy because y prime evaluated at this point is just the slope of the tangent line. Okay, and then once you know the slope and point, which is already given, 1 and 0, so you can go ahead and write down the point slope form of the equation for the tangent line. Okay, is this clear? So if not, just put it in the chat box. So I didn't finish the whole thing, but again, from this moment on, you're just solving for y prime. That's it. Okay. All right, great. So now we're going to continue with deriving more rules of differentiation. And one thing that we didn't do before the spring break was to go over the derivatives of inverse functions, and in fact, inverse trig functions as well. So, so today, this is exactly what we're going to cover. Hopefully, this is not going to be a long section. And if we have time left at the end, I will try to go over examples. Okay. So Again, today's topic is the derivative of an inverse function. So, but before we hit the road, we want to know, or we want to make sure that the inverse of the function that you're interested in first exists, right? So we want to make sure inverse exists, so I can talk about the derivative of the inverse function. So to make sure that we have a little fact check here. So we have a function f. It's defined on an interval. If f has an inverse, then the following two statements should be true, which essentially means that f is continuous on its domain, and f inverse is continuous on its domain. And if f is differentiable on the interval containing c, and f prime of c is not equal to 0, then f inverse is differentiable at f of c. Okay, so so this is something that the existence of the inverse function is something that was covered in the preliminary section, the pre-calculus section. But this theorem says, like, if you have the inverse of the function, if it exists, then it's got to be continuous for sure, as long as f is continuous. And if f is also differentiable, if you can use the rules of differentiation to take the derivative of that, as long as f prime at c, the point that you're interested, is not 0, in other words, the slope is not 0 at the point, then you can just say that f inverse is also differentiable at f of c. And then this next fact tells us about the rule for taking the derivatives of inverse function. In fact, this is what we're going to use in the next few slides. So let's say, like, you have a function f that is differentiable, so that's good. That means that f inverse is going to be differentiable as long as f has an inverse, okay? And as long as f prime at g is not 0, then the inverse function's derivative is given by this formula here. G is serving the role of f inverse, okay? So again, f is given, differentiable. So if you think that f is an inverse, and call it like g, but again, in this case, g is the f inverse function, as long as the bottom is not 0, which is f prime of f inverse of x, then the derivative of the inverse function, which is g prime of x, is found by this formula. So it's the reciprocal of f prime of g of x. In other words, it's like 1 over f prime f inverse of x, okay? And what is that again? That is the derivative of the inverse function. Okay? Because again, g is playing the role of f inverse, okay? So that's one thing, and I'm going to use this formula all the time, okay? That means, by the way, just staring at this formula a little bit, to find the derivative of the inverse function, you first need the derivative of the original function you start with, and as well, you need the inverse function. So to find the derivative, you still need the inverse function's expression. Otherwise, you can't calculate this. So again, two things are needed. One is the derivative of the given f, and second, you have to find what f inverse is, okay? And finding f inverse is the topic of pre-calculus, okay? And one fact that comes along with the pre-calculus part of this course is that if you start with this f function, let's say this graph, okay, and the graph of f inverse is found by taking the symmetry of the yellow graph here with respect to the y equals x line. So essentially, the graph of f inverse is going to be looking like this. So essentially, y equals x line is playing the mirror role, right? So you just look at the reflection of or symmetry of the graph of y equals f of x across y equals x line and boom, you have the graph of F inverse. Okay, so this is sort of like geometrically how you find the graph of F inverse, but it doesn't really tell you much about how you find F inverse of X algebraically. Right? So, well, the graph is also helpful, but in the formula, as you see, I need the expression of, I need this expression here so that I can calculate the derivative of the inverse function. Okay. So here's one example. By the way, from this graph, I can also deduce one more thing. You see like the point AB that is on the graph of F, which essentially means that the Y value is achieved at A, right? So F of A, in other words, is equal to B. When you look at the inverse function, so as you see that this point reflects all the way to the other side as switching X and Y coordinates. So for the graph of F inverse, now B and A, the point B and A is on that graph. So essentially, that means as F inverse of B is equal to A. Okay. So if this is provided to you in some context, then F inverse of this guy has to be equal to A. Okay. This is also how you look at this. So speaking of that, what is the value of F inverse of X when X equals 3? So in other words, the question is asking like, what is F inverse of 3, right? So if that's the question, why don't we call, oops, I can't write. Why don't we call that X? Okay, so this is exactly what we're being asked. So why don't we call it X? And I know how to read this, right? I know how to read this. Let me just rewrite that. F inverse of 3 is X. I know how to read that. In fact, F of X has to be equal to 3. So you can always like go back and forth between these two expressions by using F and F inverse functions. Okay? So that means I'm looking for an X for which the value is 3. The value of F at that X is 3, which essentially means that I am trying to solve this equation. So if there is a solution of this equation, then this is exactly what I'm looking for. That X, which solves this equation, is the X that I'm after. Okay? And how do we know even to start with that F has an inverse? Well, you can graph the function. You can graph the function, which is this black graph here. Okay, let me just highlight this. And it's a one-to-one function. And this is coming from pre-calculus. If your function, if the graph of the function passes the horizontal line test, then it's invertible. So that the inverse exists. And here we go. No matter what horizontal line you pick, it's going to cross the yellow graph at only one point. So by looking at the graph of the function, I can immediately say that it's invertible. So we know the inverse exists to start with. Okay. All right. So then you solve this problem of like finding the X for which this equation here holds true. Okay. And turns out that 2 solves this equation because 1/4 2 cubed plus 2 minus 1. So this is 8. So 8 divided by 4 equals 2. So 2 plus 2. So this is 2. 2 plus 2 minus 1 equals 3. So we do know that X equals 2 solves this equation by an ad hoc checking what kind of like X may solve this, and then X equals 2 sort of flashes over there. So you can go ahead and then type here that F inverse of 3 equals 2. Okay. In the future, we will try to find the root of this equation or roots of this equation by using more algebra. But this is a cubic equation, and then we don't really have much to do to solve the roots of cubic equation, because we have a formula, but that's very complicated. So you just basically find it by trial and error. If the equation is a cubic equation, all right? So it's good news that we have f inverse of 3 equals 2. And now I'm going to use the formula for finding the derivative of the inverse function at 3. Okay? So what is that? Going back to this formula that I just showed you, it's the reciprocal of f prime of f inverse of x. So the point of consideration is 3. So it's going to be 1 over f prime, f inverse of 3. Okay? Well, f inverse of 3 is just found to be 2. So all I need to do is to calculate f prime at 2 to finalize this whole process. Okay? And here we go. Well, f x is 1/4 x cubed plus x minus 1. So I need f prime of x, right? F prime of x equals what? 3 over 4 x squared plus 1. That's using the power rule. It's 3 over 4 x squared plus 1. Okay? And I need f prime at 2. So 3 over 4, 2 squared plus 1. Okay? Well, 2 squared is 4. 4 cancels this. So it takes you to what? 3 times 1 plus a 1. That is equal to 4. So going forward, so you need 1 over f prime of 2. Okay, that's exactly what I wrote over there. And that takes you all the way to 1 over 4. Okay, 1 over 4 or 1 over 4 here. Okay. Cleaning this a little bit up again, f inverse prime at 3 is going to be 1 over f prime of 2, and I calculated it in the previous slide, and that was in fact this calculation here, that f prime evaluated at 2, so that takes you all the way to 1 over 4. What that means is the inverse function has the derivative at 3 to be exact 1 over 4. In fact, the slope of the tangent line to the curve, which is the inverse function, has to be coming with the slope 1/4. Okay? So that's exactly what's going on here. So this is the original function. So this one is the original function. And you have the slope of the tangent line, something like this, for f. So this is for f. So f prime at that point is like that. But if you're talking about the inverse function, it's derivative. So then you're talking about the tangent line on this curve. So that means that tangent line at that point should come with the slope 1/4. Okay. Is there any questions so far? If so, please raise your hand. If you go to participants in Zoom, and if you click raise your hand, then you can ask the question that you want to ask, okay? And anytime, do it, and I'll check if I can answer your question right now. Okay. At this moment, there is no question, so I'm gonna sort of proceed a little bit more. Okay. So this one just says, this slide says that at the point 2, 3, you can perfectly check f prime at 2. That's the slope of this line here, okay? And f prime at 3, that can be calculated, and it's 4 in fact. Okay? And the slope of f inverse is 1/4. So that's good news because the slope of the tangent line to f and the slope of the tangent line to f inverse at the same point of consideration, they are reciprocals of each other. Okay, so as you see, like 4 is the derivative of f prime, 1/4 is the derivative of f inverse, right? They're reciprocals reciprocals of each other, so that the product is just 1. Okay? So dy over dx, in other words, if we use the notation of dy over dx, that tells us the slope of the tangent line to the curve f is exactly equal to 1 over dx over dy. That's in fact what this is what dx over dy is the derivative of the inverse function. Okay, so 1 over the slope of the inverse function is exactly the same as the slope of the original function you start with. Okay. All right. So let's see. Let me see if I have a nice example here. There is one example here, and I can technically go through that with you, but I may also leave it as an exercise for you. The question is asking, like, can you find the derivative of this inverse, the derivative of the inverse of f, which is given as a rational function? Let me just quickly talk about this first. Well, first of all, to check if the inverse of this function exists, you can perfectly graph this function, and don't forget that you're considering x is greater than 1. So that means when you plot this function in your calculator, you should probably take the x min starting from 1, so you don't need to worry about the x is less than 1. Okay, so keeping that in mind. And the point of consideration for finding the derivative of this function is 2. Okay, so in other words, I'm being asked to find the derivative of the inverse function at 2. Okay. And using the formula here, so f inverse prime at what? 2 has to be equal to 1 over f prime f inverse of 2. I am simply using the formula. Again, remember that in this formula, G is f inverse. I am just replacing G by f inverse, and the rest is, there are 2 things to find, right? One is f prime, the other one is f inverse at 2. Okay. And f prime is sort of like a piece of cake for you, because this is a quotient, right? This is a quotient. You can perfectly use the quotient rule for taking the derivative of this function, and for finding f inverse of 2. So essentially, you set, so to find this, okay, you essentially set this rational guy to 2 and solve for x. Okay. All right, so for f prime again, for f prime, this is the application of the quotient rule. All right, and f inverse, if you do the calculations, f inverse would have the form like another rational function, 3 minus x divided by x minus 1, and this is the point of consideration. Right. As you see, like let's see, what was the point? Well, x equals 2, right? F inverse of that is 1. So this point is what, 1 and 2, and then this point is 2 and 1. Okay. And apparently, x plus 3 divided by x plus 1 set to 2 has a solution x equals 1. And you do it by yourself on a piece of paper. Okay, this gives you the solution x equals 1. Okay, in other words, f of 1 equals 2, and f inverse of 2 equals 1. This immediately follows, right? And if you use the formula, that I just gave you here. Okay, that I just gave you here. Essentially, this is 1. Let me just use another color here. So this is equal to 1. So you're finding what? 1 over f prime at 1. And go ahead and find f prime by using the quotient rule, and then plug in 1. And if you do that, the slope of the tangent line is going to be equal to -2. All right. So this is a good homework for you once you have time before you start the homework problems. So go through this example. Okay. All right. Any questions so far? If so, please put that in the chat box over there, or raise your hand. If you go to participants, there's a tool called raise your hand. So do it whenever you feel like you have a question. If I'm too fast, again, you can just ask me to slow down a little bit. But let's try to start the derivatives of trig functions, because we all talked about like sine, cosine, tan, cotangent, and secant and cosecant. And we also talked about the inverses of those, but we never had a chance to talk about the derivatives of those trig functions. So since we already covered the inverse functions for any function, so we can be specific and we can consider the derivatives of inverse functions. Okay, so this is sort of like what you're going to use in the formula card. So your arc sine, arc cosine, tan, cotangent, and secant and cosecant. For each of them, you have a formula. So by the way, we still have the derivatives, the formula card for basic differentiation rules. And the one that I'm just starting to go through are the ones, in fact, here we go. So starting from 19, 20, 21, 22, 23, and 24, in fact, are the ones that we're going to cover. We're going to start covering in the next minutes. Okay, so this is our formula card. Remember, for differentiation rules, and here we go. We got all of those covered before, and don't worry about these guys here, because this is part of sort of like Calc 2, but to be sort of consistent, we keep all the formulas, relevant formulas together. But by simply going through those formulas from 19 to 24, we're going to sort of like fill all the rules and learn all the rules, so that and you can start, in fact, using those rules in the next chapter, which is chapter 4. Okay. So essentially, let me just go over this real quick. If you have an arc sine function, and if you're talking about the derivative of that, make sure about those u guys here, because this is arc trig function of a function. So here, u is a function of x, okay? If u is x, for example, if you're talking about arc sine x, and the deal is simple, because u prime in that regard is going to be just 1. So arc sine x, or sine x prime, is going to be 1 over 1 minus u squared. In other words, if u is x, then u prime in these formulas will be over 1. Okay, so this set of formulas is more generic, more general. Okay. Again, if u equals x, then everything simplifies to what? You just switch u prime to 1, and then go with the formula, rest of the formula. Okay. All right. And make sure that you should also know how you go from one inverse trig function to the actual counterpart of that, or we can switch in between two inverse trig function. So for example, if you're talking about arc secant x, that's the same as arc cosine 1 over x. And the reason here is that If you have your calculator, and if you really want to evaluate arc functions in your calculator, you will just realize that you don't have arc secant. Right? Check now. I'll give you like 20 seconds for you to check your calculator right now that you don't have anything called like arc secant x. And I have a question here. Am I going to save this class here, or we will not be able to watch it again? Well, I made an announcement for that earlier. So this lecture is being recorded to the cloud of Zoom. But for Zoom to process it, it may take like days. Because of the traffic right now. Because I just did a sample one the other day with a friend of mine. It was like a 1 hour live session, and it took Zoom to process it like 3 days. So don't make your hopes up for the live lectures to be uploaded to Blackboard at this moment, because again, everything is so slow right now. I'm trying to, I have like a B plan. In fact, to be honest with you, I'm trying to save the same lecture to my iPad Pro, because I have 1 terabyte of storage available here. But I have to see it after the lecture. At the end of the day, I can go back and then start editing certain things and then make it available. But again, there's no promise, because I have like lectures today, other lectures today going on with other classes. So I don't really have time to go back and check what is stored in my iPad Pro. But don't make your hopes up, and try to sort of like attend each lecture and rest station. Just as a quick comment. So have you checked your calculator? So you should have realized that there is no arc secant over there. So if you want to, let's say, calculate arc secant of -2, you should sort of like convert it to arc cosine of what? 1 over -2. Right? Arc cosine of 1 over -2, which is -0.5. And I'm 100% sure that you have arc cosine in your calculator, or cosine inverse of x, whichever is more applicable. Okay, so this is just a one quick slide saying, like, don't freak out when you try to calculate arc secant or arc cosecant or arc cotan. You can always use the reciprocal idea to convert it to a known arc function that you can punch in your calculator. Okay. All right. So here we go. We have some examples here. Why don't we sort of like go through that? So let's say like I have arc sine 2x. Okay, arc sine 2x, and let me just bring back this formula card here. Arc sine of u has the derivative u prime over radical 1 minus u squared. Here we go. Let me just write it here. U prime over radical 1 minus u squared, right? Okay, who is u in this case? U is the inner function here. Okay, u is the inner function here. And who's u prime? Well, u prime is the derivative of 2x, right? If u equals 2x, u prime is going to be just 2. So using this formula, u prime is 2, and then in radical, you're talking about 1 minus u squared, and since u equals 2x, so you're talking about 2 over 1 minus 4x squared. Okay? All right, any question? There is a cleaner version of that, okay? We're essentially using the formula, nothing different, okay? And let's see. Next question is the derivative of arctan of 3x, and arctan of u has the derivative u prime over 1 plus u squared from the same set of formulas. Okay, who is u here? Well, u equals 3x, and u prime is just 3. So we plug it both in the formula, so that arctan 3x has the derivative 3 over 1 plus 3x squared, which is 3 over 1 plus 9x squared. Okay? All right, any questions so far? If so, please put it in the chat box or raise your hand. All right. There we go. Another question is the derivative of arc sine of radical x. Okay, so here radical x is our u, right? And let me just write it here precisely. U equals radical x. And to take the derivative of that, by the way, we should put it in the power form. Okay, so let's just keep it ready. And what was the formula telling us? So arc sine of u prime is equal to u prime over 1 minus u squared, right? Okay, so let's first find u prime by using the power rule. Well, 1/2 x to the power of 1/2 minus 1, right? Let's simplify this. 1/2 x to the power of negative 1/2. But remember that we don't really keep negative powers as is, but we convert that to the reciprocal. So this is 1 over 2 times x to the power of 1/2, okay? Which is 1 over 2 radical x. You see the algebra here? So this part is the application of the power rule, and the rest from here to here and here to here, these are all algebra steps. Okay, so then going back to this formula here, u prime is 1 over 2 radical x. Okay, and this is divided by radical 1 minus u squared. And let me just write everything precisely so you can actually follow everything. So that's u being placed in the formula. So now let's simplify this. 1 over 2 radical x. First, let's simplify the bottom. So you have radical x, and you take the square of that. That's going to be just x. Okay? And then 1 over 2 radical x divided by radical 1 minus x is 1 over 2 radical x times what? Radical 1 minus x. Okay? So I'm using here a quick algebra. A over B over C is equal to A over B times C. Okay, this is the algebra I'm trying to use from here to here. All right. Any questions so far? We still have like 10 more minutes. That's good because I still have stuff to cover. If you don't have any question, I'm going to continue covering more stuff. Okay. Here is an exercise that maybe we can go through all together. Let's just read the question. Show that the slopes of the graphs of f and f inverse are reciprocals at the given points. Okay. So f is provided to be like 3 minus 4x. The point is 1 and negative 1. And f inverse, well, how nice this question is. It's just provided to you. F inverse is given to you rather than you finding it by yourself. It's 3 minus x divided by 4. 3 minus x divided by 4. So that's good. It's already provided to us. Well, for f inverse, remember that the x and y coordinates like switch. So the point that passes through the graph of f inverse is negative 1 and 1 after you switch. Okay. So this question is asking, like, find the slopes of f. Find the slopes of f at 1 and f inverse at negative 1. So again, 2 things are being asked in this question. What is the slope of f, which is f prime at 1? That's one question. Okay. And another question here, what is the slope of f inverse at -1. Once we have these two slopes, you want to show that they are reciprocals of each other. Okay. All right. So let's first start at f prime. That's easy. F prime is the derivative of 3 minus 4x, and that is just -4, and that's good because there's no x relevant term in the description of f prime. F prime is fixed, constant, -4. So in fact, the slope of f prime, the slope of f at 1 is just -4. And for the other one, I have to use the formula. F inverse prime at -1 is 1 over f prime f inverse of -1. Right, this formula was something that we derived earlier, so that's a good application of that. So the good news is that f inverse of -1 by just reading that point is in fact the y coordinate here, right? So that's just 1. So all I need to worry about is f prime at 1. Okay, but f prime is just constant. We just found that as a constant, right? So no matter what point you're considering, it doesn't matter. It's just going to be 4. So this bottom piece here is always 4. Okay. Okay. So then finalizing this question, well, this number here, let me just use another column. This number here and this number here are negative reciprocals of each other. Okay. Let me see if I made this correct. 1 is -4. Hold on, I think I made a mistake here. Yeah, so 1 over f prime of g of x. I think I made a mistake somewhere. Hold on. That's 1/4. F prime at 1 is -4. Oh, this is -4. I'm sorry, because f prime, as I said, f prime is constant, so this should be -4. I'm sorry. I said something correct, but I did not write correctly. Here we go. So f inverse prime at -1 is -1/4, and then f prime at 1 is -4, and in fact, these guys are reciprocals of each other. Okay. Sorry about the confusion. If you don't have any question, we still have like 7 minutes, 8 minutes. In fact, I want to go over this question to apply the rules for inverse trig functions to be applied for this question. If you don't mind, I'll just try to go through that real quick. Let me see if you have any question. Put it in the chat box or raise your hand, whichever is applicable. All right, so this question is sort of like an application of the implicit differentiation and using the rules of differentiation for inverse trig functions. So the question is asking, like, use the implicit differentiation to find an equation of the tangent line to the graph of the equation at the given points. So let's just remember what the implicit differentiation is. Essentially, we're going to take the derivative of the whole equation. Okay? We're going to take the derivative of the left-hand side, the derivative of the right-hand side, but keeping in mind that whenever you take the derivative of the y-related term, you should have some sort of like y prime coming along or tagged along with the derivative. So here we go. Let's do it real quick. R sine x prime plus r cosine y prime equals pi over 2 prime. Okay. All right, so for arc sine, we have a formula. Oh, how I got -1/4. Let me just finish this first. I'll go back to your question, Dalton. Okay, I didn't see it on time, so I'll go back to that question. Let's continue with this. Arc sine has the derivative of what? So you can scroll down through the lecture notes and you can just check that arc sine has a derivative of 1 over 1 minus x squared. Okay, and our cosine has the derivative of negative. So since the inner part is a function of x, remember that I have to treat y as a function of x, like u. So it's y prime divided by 1 minus the inner part squared. And pi over 2 has the derivative 0. Okay? So that's good news because I can solve this equation for y prime by adding the positive of this to both sides to get what? Y prime over 1 minus y squared equals 1 over radical 1 minus x squared. All right? By simply adding y prime over radical 1 minus y squared to both sides of the equation, this is what you get. And solving for y prime means multiplying both sides by radical 1 minus y squared to get, let me use another color here, to get radical 1 minus y squared, radical 1 minus x squared. So this is, in fact, the explicit description of y prime. Okay? The good news is once you know y prime, you know the slope of the tangent lines at any point, and in this particular case, we need y prime at radical 2 over 2. Okay? So let me just start from here. Let me just copy what I got. Y prime is radical 1 minus y squared divided by 1 minus x squared. And I need y prime at radical 2 over 2. Okay? So that means x is going to be radical 2 over 2. Y is going to be, this is your x coordinate. This is your y coordinate, right? So if you see y-related term, that's going to be radical 2 over 2 squared. And x term is going to be the same. Okay? And then who is this guy again here? That is the slope of the tangent line, right? Tangent line. Okay? So why don't we calculate that? So y prime is going to be equal to 1 over radical 1 minus 1 half, radical 1 minus 1 half. Well, you see like the top and the bottom is the same. So division of two numbers which are the same is equal to 1, no matter what those numbers are, without using a calculator, right? Top is the same, bottom is the same, so the slope is going to be just 1. Okay, you can go ahead and write down the tangent line because you know that the slope is 1, right? And the point of consideration is this. So here we go. Let me use a different color here. So y minus the y coordinate of the point equals slope, which is 1, times x minus x coordinate of the point. Okay. So that ends the question. And if you really want to convince yourself visually, you can actually graph this function implicitly. And one quick observation here, which is very interesting. If you ever try to graph this function together with the graph of the tangent line, you will see that both equations are lines. So you may think that how in the heaven the equation for this, like this equation would yield a line, but interestingly, arc sine plus arc cosine equals pi over 2 spits out a line, which is in fact the blue line here. Well, if you have a line to start with, the tangent line to that line at any point is going to be the same line as you see that the red line, which is the tangent line at that point, is the same as the graph that you start with. That's arc sine plus arc cosine equals pi over 2. Okay, that's a very interesting coincidence, to be honest with you. Okay, so going back to Dalton's question here, so F inverse here is calculated as 1 over F prime of F inverse of -1, but F prime is, as we found here, is constant. So this bottom here is going to be always -4, right? So the bottom here is always -4. so that this whole 1 over the bottom becomes what? 1 over -4, which is -1/4. And as you see that these two guys are reciprocals, right? Reciprocals of each other that way. I just forgot to put the minus sign here when I was doing this the first time, but f prime at any point is constant, and that's -4. And plugging that -4 here yields the derivative of the inverse function to be -1/4. Okay. All right. So, do you guys have any question? Because you're almost like a minute away from the end of the lecture. It's the best time to ask questions if you have any. I'm glad that all of you made it, because I have like 25 people, including me. So like me joining that from 3 different devices. So 25 minus 3 should be the number of people. There may be some people missing currently, maybe 1 or 2. I haven't had a chance to check that. But this is going to end our lecture. If you don't have any question, I have my final recommendation to you. Just keep an eye on my emails and Blackboard side and check the announcements, relevant announcements. And whenever you feel like you have a question, please do not hesitate to send me an email. Okay? So, and I will have an office hour today, virtual office hour at 2. Welcome to, well, you should just feel welcome to join my office hour. Normally, not many students pop up in face-to-face type office hours, but it's a virtual office hour. So please join and ask your questions. So this whole thing ends section 3.6, and next time I'm going to start 3.7, for which you have lecture notes already available in Blackboard. So I'm going to end this session since nobody is asking a question. Again, you can always ask your questions privately by email. And good luck with your other courses today. And hopefully you did not have any issue at this moment with me teaching this lecture to you. If there is any like technical difficulty or any other problem, just let me know by email. All right, have a good one. So good luck with other classes. Bye.